Hey guys, this is question MM090 of the Maths Methods Sharpened Study Guide. Consider the simultaneous linear equations x take away k take 3 times y equals 5 take k, that's our first equation, and our second equation is k take 2 times x minus 2y equals 2, where k is a real number. Find the value for k for which there are no solutions. So no solutions basically means no points of intersection between these two graphs when we graph them out. And the only way that we're going to be able to work that out is if we put these into y equals mx plus c form. So let's go ahead and do that. We'll start with our first one. So our first one is x take k take 3 y equals 5 take k. And we want to get this in the form y equals mx plus c. So let's go ahead and start trying to do that. So we just take that x onto the other side. And to get y by itself, we divide everything by negative k take 3. Which is the same as 3 take k. So I'm going to put this x at the front so that we can have it in the mx plus c form. So this is negative x over negative k take 3. I'm just dividing both sides by that. Plus 5 take away k over negative k take 3 is the same as 3 take k. So this is 3 take k. And these two negatives both cancel out. So we end up with y equals 1 over k take 3x plus 5 take k over 3 take k. Awesome. So this is our first sort of modified equation. And we've got our second equation, which is k take 2x take 2y equals 2. And we want to get y by itself again, so we get negative 2y equals negative k take 2x plus 2. And dividing both sides by negative 2, we get k take 2 over 2x take away 1. This is our second modified equation. Awesome, so now that we've got both of the equations in the form y equals mx plus c, we can actually compare them. So if there are no solutions, as in the gradient is this, sorry, I'll take a step back. There's no points of intersection, which means that the graphs run parallel, which means that their gradients are the same. However, their c value or their y-intercept are different. So the c values cannot equal each other, and if they don't equal each other, then we will have no solutions. So let's start with the gradients, because we need to actually figure out what values of k produce the same gradient first. So we basically just let m1 and m2 equal each other. So we get 1 over k take 3, which is our first m value, equals our second k value, which is k take 2 over 2. Expanding this out, we get, if we multiply both sides by 2, we get 2 on this side, that cancels out. And if we multiply both sides by k take 3, that cancels out there and becomes k take 2 times k take 3. Expanding all this out, we get k squared take away 5k plus 6 equals 2, which means that 0 equals k squared take 5k plus 4. Awesome. This is a simply factorizable expression, which changes to 0 equals k take 4 times k take 1. Reason being, negative 4 times negative 1 is equal to positive 4, and negative 4 plus negative 1 is negative 5. Awesome. So from here, that means that k is equal to 4 and k is equal to 1. So basically, we've got the values of k that give the same gradient for both of these. And now we need to test these k values to see which one yields a different c value. So we've got k is equal to 4 and k is equal to 1. And our first equation is shown here, which means we've got y equals, let's move all this up for you. We've got y equals, actually, you know what? Let's not worry about that. So what we're looking at is our c values. So we want the c values to be different because that means they'll be parallel like this. So our first c value is 5 take away k over 3 take away k. And our second c value is negative 1. So if these two equal each other for these values of k, then it will have infinitely many solutions. And if it has, if the c values don't equal each other, then it will have no solutions. So basically what we do from here is sub in the k values and see what happens. So we'll start with k equals 4. and we get 5 take away 4 over 3 take away 4 equals negative 1, which gives us 1 over negative 1 equals negative 1, giving us negative 1 equals negative 1. Therefore, C1 equals C2, which will give us infinitely many solutions, not no solutions. So it's not k equals 4. What we do now is test again with k equals 1. 5 take k over 3 take k equals negative 1. And if we put in 1 here, we get 5 take 1 over 3 take 1, which is 4 over 2, which clearly does not equal negative 1. Therefore, and I would actually write this, therefore k equals 1. Well, I would actually say no solutions when k equals 1. Find the value of k for which there are no solutions. We've done exactly that. We've sort of discounted the one that makes it so that there's infinitely many solutions. And we've kept the one that has no solutions, so our answer is k equals 1.